Hello friends, welcome back to the bench. Our patient is a 2001 Subaru Outback. This is LL Bean edition, well, not but. LL Bean editions come with a 3-liter 6-cylinder engines, but this one has a single overhead cam as opposed to later versions of LL Bean. Now, the part number is AA98D. And what is the problem with it? Well, it's actually a very curious case. The first one of its kind. So typically when I receive ECMs, the faults that are described are either, no injection on certain cylinder, no ignition, maybe no ignition on all cylinders, or just one. Some kind of obscure faults, like the fan not turning on, or fan constantly on, shorted transistor. In some cases, are like there's no signal, knock sensor not responding, the evap not working, or those kind of faults. Now with this one, the only description we got from the customer is it is a no start issue. That's all we know. But so what I told the customer, sure send it in, because meanwhile I ordered a replacement. So I figured, okay, it doesn't really matter what's wrong with yours, because I'm just gonna clone it to the replacement, and with the original I'll just do some testing, and if I find a fault I'll fix it. If not, you're still getting the replacement. But this one, it's actually a little bit beyond my abilities, because this is 2001, which is kind of surprising, but it doesn't use CAN line communication or a CAN bus communication. Instead, what it uses is a K line. It is called SSM/GST communication line. It's a single wire communication line, and you can technically it should work the same way, right? So every adapter will have the CAN high, CAN low, and on top of that it'll have a K line, right? So you just connect the K line instead of CAN high and low, and you should be able to read the ECM the same way. But it seems to be beyond the capabilities of my devices. Plus, I've never actually used K line before. I guess the models that I typically work on are 2005 and older, and they all use CAN. But with this one, on top of that, because this is what I wanted to do, I wanted to read the codes to see what the problem is, but I'm unable to. So I want to clone it, but it looks like these don't need to be cloned. I could be wrong about that, but so far I asked around, and there's a good chance that these don't need to be programmed. They don't have a VIN installed in it, or written to it, despite customer writing the VIN on the case. I'm not sure about this, but here's what I can do. So obviously we're gonna send the second ECM to the customer, and they'll see if it actually does need to be programmed or not. Hopefully not. If so, then we're gonna solve that problem when we get to it. But what we can do is perform a very boring visual inspection, which I already did. I removed the entire conformal coding from the entirety of the board. So the board is completely naked, which makes it very easy to to probe around. Now for the ignition, we have the same chip that comes in, pretty much all of the Subaru ECMs. This is the chip that controls the ignition, right? Looks like we have 2 resistors here instead of 4. So this could mean no. There's no way. It's gotta control ignition on all 6. Because I was thinking sometimes they have just 2 lines for 4 cylinders, but this is 6 cylinders, so there's no way to do it with 2 lines. I mean, yeah, probably not. But if there was an ignition problem, we can replace this chip. There's not much in between it. This is the only thing in between the MCU and the engine, right? So typically replacement of this resolves the problems of ignition. Injection is controlled by these transistors over here. 6 of them. There's 7. So either T808 or T852 is responsible for something else. The rest is the injection. So that would be the injection problem, and other problems like sensors and stuff. One of these little resistors could be responsible, although these transistors are controlled by these little transistors here, which in turn are controlled by the MCU. All right, and it looks like it is a Denso. Is it? There is a little D, but typically Denso come with the logo, Denso logo. We do have this is definitely Denso. This is Denso as well, but this one doesn't. There's a D, but that's not a Denso logo, so I'm not sure. So maybe that's why this doesn't need to be programmed. Now you can see a little damage over here on the cab, but that's from ultrasonic cleaning. I will recap it as well, just to be sure. But I don't expect issues there. We obviously can check whether we have 6 megahertz on the crystal, but I don't expect issues there. And there should be a second crystal right here, which is 8. What is it? 8 kilohertz? No way. Not sure what the frequency of this is, but this supplies this chip, and the 6 megahertz goes to the MCU. And that's pretty much it. It's always worth checking the diodes here for the injectors. So we'll check those as well, just to make sure. But what can cause the ECM to have no start issue? Lack of no injection, no ignition. Yeah, typically those two cause no start. There could be another fault that prevents it from starting. But again, it would be easier if we could just connect and read the code. That would tell us a lot more. But we don't have that ability, so I prepared a little checklist over here. So this is what I can do. So first thing, you connect it to power source and check how much power it grabs. It should grab anywhere from, well, I have the working one so I can compare, but it's anywhere from like 2.5 watts without the ignition switch. If you switch turn the ignition switch on, it should grow by maybe 2 watts. So if that happens, then you most likely the MCU is working properly. But to confirm that, we have I prepared few lines that I want to check. So the throttle position power supply, right? We should always have 5 volts on it. regardless of the position of the ignition switch. The generator signal, it should be roughly 4 to 5 volts when the engine is off. So we can check that. The backup power supply, again, this would be represented by the codes, but we want to see 10 to 13 volts when the ignition switch is on. The sensor power supply, 5 volts, always on. We want to see 5 volts over there. The fuel pump relay control, that could be another reason for no start. There's no fuel pressure. So we want to see 0.5 volts or less when the ignition switch is on, and we want to see 10 to 13 when the ignition switch is off. And when the engine is idling, well, we're not going to see that, but it should be the same as when the ignition is turned on. And there's few more things that we could check, but that, like purge control solenoid valve, the temperature sensor. Now, can the temperature sensor cause no start? Not really. It's probably not. And it could be very obscure situation where it's cold and the engine is being flooded because of the temperature sensor saying that it's hot, or vice versa. So, you know, theoretically it could, but most likely if there's a problem with temperature sensor, the car will still run, but it's going to be rough idle, and it's going to be choking, and, you know, maybe poor power, maybe revving problems, but not no start. I wouldn't think that no start can be caused by the temperature sensor. And that's pretty much it. So let's run through the checklist and see what we can find out. Okay, so the first problem I see is that power draw is 10 milliamps. That is not what I would expect. Plus, I don't see any difference between ignition switch on and off. There should be a difference, but again, this is the first 2001 that I'm working on, so this could be different. So let's run through the checklist. We don't have a throttle position power supply. Okay, so this is curious. Let's check it. Let's turn it off. This is weird, because these three components here, typically that's like 12 volt regulator, 5 volts, and maybe 3.3, something like that. So typically you want to see on these, you want to see the voltages like 5 volts, at least 5 volts, right? Because that's how we supply the logic here, like the MCU. What I see is 12 volts everywhere across the board. So let's check for short. Let's see sensors power supply, because sensors should also always be present. And we have 12 volts. We have 12 volts on the sensor power supply. It should be 5. So there's definitely something wrong here. It shouldn't have 12 volts across the board. But that means that the MCU is fried. Let's see if we can find VCC here. Yeah, we got 12 volts here. There's no way MCU is working anymore. Well, this one does have a throttle position power supply, but also 12 volts. Could it also be, and it also takes 10 milliamps, and there's also no difference if you connect the throttle or the ignition. Now let's check different ground, because there's no body ground. It should all be connected, but same here, and 12 volts. But that one doesn't give us the 12 volts on the power on the throttle position power supply. That's better. So I connected to different ground, because there's a total of 3 grounds on it, right? Typically on these ECMs you have the separate ground for ignition and injection and sensors and the overall body ground, and I always use the body ground. Although if you check with the continuity, they all connected. These aren't separate grounds, but it is dedicated ground because more current flows here and there. But for these purposes, it's fine. You can use any ground. But I connected to ground, which is on B134, which is ground for sensors. And I get a little higher, well, much higher. Like let's start it again, and actually this time let's connect the K line. And with a K line connected, we'll check the LED over here if it lights up for the K line. It does not, but we're grabbing 4 watts. But the K line is not lighting up, which sucks. But now let's check the sensor's power supply. Yeah, now it's 5 volts. Okay. So I was just using the wrong ground. It looks like it does have separation of grounds, but the K line is not lighting up again, which sucks, because I wanted to read the codes. So let's get this one back on, and let's do it right. And weird, because regardless of whether we have the ignition switch on or off, there is no difference. So let's keep the ignition switch on, and let's get the K line connected as well. And restart. K line still not lighting up, but that's fine. Sensors are yeah, now it's 5 volts. So that is weird. Let's see this now. I got 10 on this one, nothing on this one, nothing on this one, and we have 5 volts on CPU now. CPU, well, it's not hot. It's slightly warm, but that's normal. It is grabbing 4 watts. Okay, so throttle position seems okay. Generator B137 on 12. Okay, so what we have is backup power supply doesn't seem to work, and the sensor's power supply doesn't seem to work. So that would explain why there is no start. Let's see if we can find what would be responsible for this. It's a long shot, but let's give it a shot. I don't know. I located the cap right by here, right? This is the cap, or this one, right? And there's a via, and it connects to nothing that I can find. So we don't know how this voltage is generated, but it's missing. And on older or newer models that I'm familiar with, the car will still start without the backup power supply, and it will work, but it will generate the code, backup power supply low, but it will still work. So maybe that's not a problem here. Okay, so at least one find. So the sensor's power supply is in this chip. I do not have these chips. In fact, it's the first time I see one. The newer models don't have this. They have different chips, or at least different markings. Maybe it's the same chip. Who knows? Maybe the same die, but different markings. So it would appear that this chip might be faulty, or the conditions, meaning it's not turning on because of something. Let's do one last thing and see the thermal image of the ECM when we turn it on. Let's see what's grabbing those 10 or what was it, 4 watts, just to see. Doesn't necessarily mean anything, but since we already have it all disassembled, let's just check it. Okay, I admit a defeat on this one. Nothing looks out of the ordinary under a thermal image. This is the first one of this kind that I do, so it's not like I can use my experience. And I have a working one over here. Now, the reason I don't want to just keep comparing this one to this one, because I fear I can't read either one of those, right? But I didn't try that one when connecting the ground to the other ground that turns it on. It could be that I need to connect all 3 grounds, but in either case, even if I find what's wrong with this one, we're at the in the same place, because I already have the replacement. So I want to send the replacement along with this one, and we'll see if, well, it should work, right? There shouldn't be anything. But no start not necessarily have to be because of the ECM, right? So this will also give the customer the ability to eliminate the ECM, because there is a chance that there's nothing wrong with this one. That's why I can't find anything. And it's just misdiagnosis. It happens. But at the moment, I have no idea what's wrong with this. No idea. So we're going to admit a defeat on this one, send both ECMs back to the customer, and go from there. So not much repairing today. I was going to do some motherboards, but it got cold again. So sorry. I have 3 in queue right now. So yes, I want to get them done as quickly as I can, especially since it's a free repair. But no, the weather needs to be right, because if it's too cold, it's just not gonna work. Despite my best efforts, it just doesn't work well when it's cold. It needs to be a good temperature. Plus, I don't want to be cooking in fumes with closed windows and stuff just to keep the shop warm, right? Alrighty, we'll stop here because it looks like I need to help my son with his hoverboard. He's a natural. I was so afraid of giving him to him, but he is a natural. He rides like a pro, like he was born riding that board. But there's a problem with it, so perhaps later today we'll have a hoverboard for repair on the bench. Until then, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.